Hi everyone, welcome to our webinar. Please let's wait 2 more minutes, wait for more audience coming, and then we can start. Okay, I think it's time to start our webinar now. Hi everyone, here's Ling from DJI Enterprise Marketing in Europe. And next to me is Marco, the CEO from our partner Unifly Consulting. And welcome to our 4th session of the webinar series. It's really our honor to work with our partner Marco from Unifly Consulting again. Today, we're going to introduce the SORA tactical mitigation performance requirements. And in the last 3 sessions, we already talked about some changes about SORA approvals, opportunities, and so on, which you can also find those recordings in our registrations website. If not, I can also share once more in that group where you can see on your right side. And before we start it officially, let me also introduce a little bit simply about how to use this webinar platform. So on the top right, you will see there is a question mark box. And after you click there, you can leave your questions or any comments at any time. And at the end of the webinar, Marco from Unifly Consulting will also select those questions and read those questions to answer. That's at the end for the Q&A sessions. Okay, the time is short, so I will also directly pass the floor to Marco. Hi, Marco. You can.
Thank you, Ning. Thank you very much. Good afternoon, everyone, and welcome again to the 4th session of our webinar series. I'd like, first of all, to thank DJI Enterprise for hosting me and giving Unifly Consulting the opportunity to deliver these webinars. So today's topic is kind of an important one because we will be talking about accessing the airspace. And if you are a US operator, if you are active in the drone sector, you know that accessing the airspace is probably one of the 2 key challenges that we are all facing right now and that are somehow preventing the drone sector to really grow. The other issue is the length and complexity of authorization processes, as we all know, but we already discussed about that quite extensively in the previous webinars. So today we're going to focus on how to access the airspace. And the original title that we gave to this webinar was Challenges and Solutions to Meet the SORA Tactical Mitigation Performance Requirements. But actually, while preparing for this webinar, I realized that this is actually the end of the process. So there's a lot more that operators can do before getting to the SORA tactical mitigations to make their operation feasible. So I will guide you through the whole journey, which is the air risk assessment, to see what are the options that you have to make your operation feasible and make the access to the airspace easier. So before doing that, however, let me quickly start by introducing myself for those of you who don't know who I am. Yeah, my name is Marco. I have a background as an aerospace engineer, and I've been working in the drone sector for around 12 years now. I'm currently the CEO of Unifly Consulting, a company that was previously called Euro USC. And in my everyday life, I support operators and manufacturers, authorities, everyone in navigating the US regulation. And I also provide trainings for several institutions, primarily JEA training organization and Eurocontrol. And I'm also a member of JERS, and in particular the group that developed the SORA. So this is me, and this is also the reason why I'm here trying to hopefully help you on navigating the SORA and the authorization processes in Europe. So the company I'm representing here, Unifly Consulting, is active everywhere in Europe and beyond, supporting operators, manufacturers, and authorities in navigating the regulatory challenges in the drone sector. But we do not only provide consultancy services, we are also heavily involved in research and innovation, trying always to work at the forefront of everything that is new in this sector, trying to experiment new services, new functions, and things like this. And we also provide training quite extensively. And we are heavily involved in several regulatory and standardization entities, including JARUS, but also within EuroCAE or ISO, for example. And this really gives us first-hand experience on everything that's going on in the drone sector. We operate from our headquarters in Italy, but we have partners that work with us on all over Europe and even outside Europe. So we have direct contacts with almost all the civil aviation authorities in Europe. So we are able to support our clients everywhere. But I know you're not here to listen to who we are, but more importantly, to how to access airspace in the specific category. So these are the topics we are going to cover in this webinar. So first of all, I'd like to start with an overview of how the airspace is characterized and classified in general and in particular in the SORA framework, and what are the challenges for US operators when it comes to accessing this airspace. And then we'll see throughout the SORA process how we can in the end get to tactical mitigations and what are the best strategies to meet the performance requirements that are set by SORA. And then we'll discuss some potential case studies and examples and show you how you can do this in practice. So let's get started. So this is how the airspace is structured in the SORA framework. You might be aware that in SORA, the airspace is divided into 12 different airspace encounter categories. So the most important ones are those categories that are related to the operations below 500 feet, which is what we usually call very low level. And this is where, as you probably know, the vast majority of drone operations are currently taking place. And then we have another set of categories, which instead are referred to the airspace above 500 feet, which is an area where drones are not normally operated right now, but where there are multiple opportunities to exploit. And then we have two kind of specific categories. One of them is called atypical airspace. And as you might know, this refers to airspaces that are either segregated or airspaces where manned aircraft typically do not fly. So for example, very close to the ground or close to obstacles. And then the last category is the airspace above flight level 600, which means above 60,000 feet or 60 kilometers, more or less, of altitude. But this is clearly an airspace where we don't really have activities at the moment. So within the very low level set of categories, we can clearly distinguish among three main areas, I would say. So one area are the airspaces that are controlled. So these might be so-called airport environments, so airspaces that are close to airports or heliports, or controlled airspace which are not close to airports. But it's not very common to find a controlled airspace unless you are close to an airport or an heliport. And then there's the whole area of the uncontrolled airspace, which is the vast majority of the airspace at very low level in general. And SORA is making a distinction between uncontrolled airspace over urban area or over rural area. So in principle, if the airspace is the same, there shouldn't be much of a difference. But actually, depending what are the characteristics of the area on the ground, the probability of encountering a manned aircraft in the airspace might be different depending on whether you're flying over an urban or a rural area. So that's also something that matters. So this is how SORA is structuring the airspace somehow. Now, in general, there are specific types of areas that are also defined at ICAO level. So we do have in all airspaces prohibited areas, which are defined as areas of the airspace where flight is in general entirely prohibited. So these areas are always clearly identified, and in order to fly in these prohibited areas, drone operators typically need to get a specific approval. The same applies to restricted areas, in which instead only specific type of traffic is allowed. For example, we do have restricted areas for military activities. And also in this case, US operators typically need to get a specific approval to enter these areas whenever they are active, of course. And then finally, we have the so-called dangerous areas, which are again areas that are defined as places where dangerous activities might happen. So there is no limitation in terms of accessing these areas, but operators need, of course, to be careful when accessing these areas. So in the European regulation, what happens in practice is that at very low level, below 500 feet, all airspaces that are either controlled or with some kind of restriction, so prohibited or restricted areas, are identified as geographical zones. So geographical zones are areas of the airspace in which the states may, for example, prohibit all UAS operations, or they might request specific conditions to access, such as the need for getting a flight authorization. Or they might request the UAS to be following specific environmental standards, or they might allow access only to certain US classes, or, for example, to UAS operated only in the specific category. Or finally, they might require that the US is equipped with the remote identification. But this is already a requirement for all US in the specific category, so it's not really relevant. So why I'm mentioning the geographical zones? Because what happens in practice is that the vast majority of the airspaces where the risk of having a collision with a manned aircraft is higher are already often identified as geographical zones, in particular at very low level. So if we take a real example, and this is Belgium, for example, where our home company is based, you see that the map shows a number of geographical zones, here depicted in orange. And everywhere you don't see these geographical zones, it means that the airspace is uncontrolled, so class Gulf. Everywhere else you have an orange area, there is a geographical zones which will require a specific flight authorization to be obtained by the operator. So whenever the flight authorization is obtained, then what happens in SORA is that that operation often becomes as it was carried out in an atypical airspace. So the need for tactical mitigations, it's already no longer there. So the real challenge for US operators is not really to operate in geographical zones, because assuming you can get the approval to fly there, then you are almost done. The real challenge is to operate in the other airspace classes, in particular in the class Gulf airspace. So, for example, when it comes to managing the activities inside the geozones, what they did in Belgium was to appoint a manager for each geozone, which is responsible for, first of all, developing a procedure to have clear criteria on how US operators can get an authorization to access that airspace. And of course, these procedures must guarantee that there is an equal treatment between all US operators. And then, of course, the authority has always the right to revoke the designation of the manager if the requirements of equal treatment and transparency are not met. So inside the geographical zones, what is required is by the US operator to obtain a flight authorization from the geozone manager. And this is always required, for example, every time the operation is conducted near an uncontrolled aerodrome, a civil airport, any kind of aeromodel or general aviation fields, over ports, within defined US test ranges, or over royal properties. So this means that all these areas are inside geographical zones, and to access these areas, the operator needs to get a flight authorization. However, this flight authorization, despite having a name that is kind of confusing because it's the same name of the operational authorization, this one, the flight authorization, it's only an administrative procedure, meaning that there is no risk assessment involved. Or better, the risk assessment is carried out on the side of the geozone manager when the flight authorization is issued, but there's nothing the operator needs to do on this side. So going to the risk then. So right now, I would say that the vast majority of US operations are conducted below 500 feet. And if the operation is in controlled airspace, the area is likely going to be inside a geographical zone. If it's not, then SORA is going to assign an initial level of risk, which is defined as ARC-C. The same applies to operations that are in uncontrolled airspace over urban area. While if the operation is in an uncontrolled airspace over a rural area, SORA gives a lower level of risk classified as B. And finally, what often happens is that the operator can claim that the airspace is atypical, for example, because you are operating close to a power line or any other obstacle, or very close to the ground, typically up to 30 meters, then the airspace is atypical and you get the lowest level of risk, which is level A. So these are the initial air risks that are more common. Now, in principle, it's possible also to be operating in some of the other categories. But especially if you fly in controlled airspace, you will always need to coordinate with the entity that is managing that airspace, and that will already require to implement specific mitigation measures in order to get access. So I would say that right now, the main challenge is to operate in uncontrolled airspace below 500 feet over either urban or rural area. So what SORA classifies as airspace encounter category 9 or 10. So the first question is, but can we actually operate with a residual air risk class that is C? Well, the answer is no. Right now, operating at a residual air risk class of C would imply being in a SAIL level that is at least 4. And since operating at SAIL 4 requires, in Europe, to use a drone that has obtained a design verification report for EASA, and the operator must have obtained an LUC, a Light US Operator Certificate, well, I think it's clear that this is something currently not possible. First of all, because there are only 33 LUCs that were issued in Europe, so I guess most of you don't have an LUC. And secondly, and most importantly, because right now there's no DJI drone with a design verification. And I don't think that's ever gonna be, but not because DJI doesn't want to get a DVR, but because it doesn't really make sense to undergo the design verification process just to get to a residual risk of C. There are other solutions, actually. So the first challenge for any US operator is to make sure that the residual air risk class is maximum B. However, residual air risk class, it's not the initial that we have seen here. It's something that we can somehow obtain by implementing proper mitigations to reduce the initial air risk to a lower level. And how can we do that? So in SORA, there are two different types of mitigations that are called strategic mitigations for the air risk. So the first step of these strategic mitigations is called by operational restrictions. So the first option is to claim that there is a restriction by boundary. So this would mean, for example, flying below the highest obstacle, but far from the obstacle. So you know that in order to claim that the airspace is atypical, you need to be flying at no more than 10, 15 meters from the obstacle. So you might need to be flying farther away from the obstacle, but if you are still flying below the height of the obstacle, you can claim that the probability of having a mid-air collision with a manned aircraft at that height is definitely much lower than the probability of having a collision everywhere else inside that uncontrolled airspace. The second option is to claim that there is a restriction by chronology. So this is something that might be applicable, for example, for night flights. So during the night in uncontrolled airspace, there's typically less traffic than during the day. So that's something that the operator can use as a justification of a reduction of the initial air risk. The third option is called restriction by operational time of exposure, which means reducing the duration of our operation. However, this could be quite limiting. So it might not be available unless the operator actually has flexibility in managing the duration of the mission. The second set of mitigations are called by structural rules. So this means flying in airspaces where there are common rules or common structures that are available for all airspace users. So this would mean, for example, flying in a U-space airspace, or flying in a controlled airspace where air traffic control requires coordination before takeoff. So these are the typical examples. So using these mitigations properly, the operator should try to prove to the authority that the initial risk can be reduced to a lower level. So potentially going from C to B. Now, the real challenge here is that the implementation of these mitigations is very subjective. So it's purely based on expert judgment. And right now, we have very limited guidance on how to do this. So the best way to actually convince the authority that the mitigations are effective is, first of all, by having and showing a good knowledge of the airspace you are flying in terms of what type of manned aircraft you expect there. Emergency helicopters, gliders, paragliders, anything, okay, like this. And the second thing is to engage as early as possible with the authority, discuss with them about how they see the airspace you want to fly in, and come to an agreement about what is the actual level of risk that can be considered. So what are some of the options? So how can you kind of ensure that your residual air risk class is going to be B? So first of all, and these are you see here, it's just a list of potential options. You don't necessarily need to do all these things. Maybe just one of them would be enough, depending on the scenario. So some of the strategies include making sure that you're not flying inside a controlled airspace, because controlled airspace typically means that there is a higher chance of encountering a manned aircraft. And you will definitely need to coordinate with some kind of external entities. So make sure that your operation is sufficiently far from areas where manned aircraft typically take off and land, airports, helipads, which are typically included in geographical zones, but also areas which might not be inside geographical zones, like paragliders areas or airfields for ultralights. So if you are sufficiently far, you can. It's easier to claim that the probability of encountering a manned aircraft is reduced. Flying again far from sites where there are model aircraft clubs or associations, or areas that are used for military operations. Then another action that the operator can do is assess what's the likelihood of having other manned aircraft in the intended volume, so where you expect to fly, and in the adjacent volumes. And again, this will be related to the knowledge of the airspace that the operator can get and the presence of areas where you have, for example, typical glider flights or things like this. Then another key element would be determining if at least 50% of the manned traffic is cooperative, which means equipped with some kind of system that is broadcasting its position and heading. So this is, for example, ADS-B, right? So if traffic in the area is conspicuous, at least 50%, then it's going to be easier then to claim that the risk is reduced, and also that you're able to detect that traffic. And this will be then needed in the tactical mitigations. Then, if it's possible, for example, to notify the other airspace users before takeoff, that would, of course, help in reducing the probability of encountering them. And this can also be supported by the competent authorities that may establish specific notification systems, except a U-space, so something that is going beyond U-space or instead of U-space. So how to actually do this in practice? So the first step would be doing some data gathering. So collect data from competent authorities or stakeholders, if available, about the typical occupancy of a given airspace. However, getting this data, it's not easy and it might be quite expensive. So of course, this is, I would say, a last resort. So only if there is no other way of demonstrating that the airspace has a lower level of risk, you should go that way. And then again, try to analyze what is the expected percentage of manned aircraft that are equipped with some kind of cooperative identification system. Then you should move to a more local analysis. So trying to understand what type of aircraft you expect in the operational volume and how much they are expected to fly in that area. What is the time they usually spend at very low level, and how many of them, once again, are equipped with, for example, ADS-B or FLARM. Then, if you are able to calculate the total number of flight hours that this type of aircraft perform at very low level, this might help you in demonstrating that the probability of having a mid-air collision is reduced, and therefore you can actually claim that your residual risk is ARCB. And then you will need, of course, to adjust all this for local restrictions and environmental conditions. So, for example, if in an uncontrolled airspace you typically have only VFR traffic, visual flight rules, flying during the day, then if you fly at night, you can expect a much lower traffic density. Or again, if in a given airspace you only have visual traffic rules, traffic, VFR, then if there's a cloudy environment, you can expect this aircraft not to fly within clouds or close to the clouds. So these are also other things that you can consider. So, but the question then is, what if there is no strategic mitigation that is sufficiently effective to get our residual risk to B, and our risk remains C? Well, if that's the case, right now there are only two solutions that are available. Get a temporary segregated area, which is requested to the authority, activated through an OTAM, for example, and this would, of course, make your airspace atypical, reducing your air risk to A, and also completely eliminating the need for using tactical mitigations and following the SORA performance requirements. However, there is a big limitation related to this. First of all, that authorities may not be willing to grant these segregations, and if they do, this is going to restrict the access to the airspace to other airspace users. So of course, this is not a solution that we can afford in the long term, because we can't really restrict the entire airspace. So the other solution should be, in principle, the implementation of USpace, because USpace is meant to reduce the residual air risk to B. And this is done by definition to some extent. So the regulation is directly saying that wherever USpace will be implemented, the residual risk will be B. And USpace services will also support compliance to the tactical mitigation. So if USpace is there and you rely on the USpace services, then there's no issue anymore in accessing the airspace. However, we all know that USpace is not there yet. There's only one USpace that is currently active, and that's actually in Italy, but I can tell you there's nobody flying there. Because as you might have heard, Amazon, that was supposed to start operations in that USpace, decided to discontinue their activities in Italy. So there is a USpace, but it's actually not really used. And why is that? Well, because implementing USpace, it's very expensive. And unless there is a significant demand from US operators, there is no business case for implementing USpace. So we are not going to see USpace everywhere anytime soon. So we hope, and there are discussions ongoing with the European Commission and the EASA, that there will be an update in the regulation that will allow offering only specific services which can help operators in accessing the airspace without the need of having a fully deployed USpace airspace. But we'll see how that will go. So if at the end of the day we get to a residual risk of B, what can we do? How can we comply with the tactical mitigation performance requirements? Well, there are different options, but the key requirement is that we should be able to detect 50% of the traffic in our volume. So how to do this? Well, there is no single solution. It really depends on the characteristics of the airspace, what type of traffic you expect there. And this is why the data gathering and the initial assessment that you need to do in the previous phase, it's fundamental to make sure that the tactical mitigations you propose to the authority are accepted. So, for example, if you're able to demonstrate that at least 50% of the traffic is equipped with a DSB, you can, of course, tell the authority, I'm using ADSB and I will be meeting the detect performance requirement. Otherwise, you might need to look at other solutions, which might be monitoring radio communications, using other systems like FLARM, and in the worst case scenario, rely, for example, on ground-based radars, which, however, are very expensive. So it only makes sense to buy such a system if you are planning to operate in the same area with a large volume of drones. So it's something that makes it worth it. The other requirements are instead much easier to comply with, because the decide function is simply requiring that the pilot is able to take a decision in a reasonable time. A reasonable time might be even 1 minute or 30 seconds, depending on what is the expected speed of the other aircraft in the area. Then the command requirement is also quite easy to fulfill, because it's required that the latency of the command and control link is less than 5 seconds. But this is something that is already supported by all command and control links that are currently operated on DJI drones, for example. And then we have the execute. And again, here, it's sufficient that the aircraft is able to descend and land, for example, or go below a safe altitude in less than a minute. So kind of easy to do. And then feedback loop means that the system you are using to detect the traffic must have an update rate of less than 10 seconds. But this is also something quite easy to do. And then we also have requirements for integrity and assurance. But at the level of integrity, there's not much you need to do, because you can simply buy a commercial off-the-shelf product, an ADS-B antenna on Amazon, for example, that would work, and there's nothing else you would need to prove. And at the end of the day, all this will just be declared. Of course, authorities may require to provide some evidence, but we expect that while going forward, authorities will ask for this evidence less often. So the message here is that at the end of the day, the key challenges when it comes to accessing the airspace are, first of all, to reduce the risk to a maximum of B, and then for tactical mitigations, the key challenge is the detect function. So finding the right system, the right technology to be able to actually detect at least 50% of the traffic in the volume. Of course, if you are able to fly in a typical airspace, then you have no requirement here. But as we already said, flying in a typical airspace is quite limiting. So there's not really much you can do about that. So let me give you an example. Let's say you want to operate beyond visual line of sight in a class Golf airspace, and you are already far from any airport or heliport. So first of all, airspace classification. So class Golf means that the airspace is uncontrolled. And there are many different types of uncontrolled airspace. And the levels of traffic of manned aircraft might be very different. So what is going to determine the actual residual air risk class is going to be the density of the observed traffic. So SORA distinguishes between uncontrolled airspace over urban and over rural. But actually, what matters is how much traffic you can expect in that area. So you shouldn't really pay attention to whether the area on the ground is urban or rural. You should think about the traffic density. So for example, if you're flying over a rural area, you can always claim that the residual is B. However, if in the rural area you can expect a high density, low altitude traffic, for example, glider routes, parachuting, and so on, you might even need to give it an air risk class of C, even if the area on the ground is rural. On the other side, if the area on the ground is urban, you are allowed to give it a residual risk of B, unless you expect a high level of tourist or police helicopters at very low level, which in Europe, I can tell you, is very rarely the case, because over cities, the minimum altitude for manned aircraft is typically 1,000 feet, so twice the limit of very low level. So in general, operations over urban areas in uncontrolled airspace can be classified with a residual risk of B. if unless you are not able to, or I mean, it's clear that there's a lot of helicopter traffic, then you might need to use a residual risk of C in this case. So again, what the operator is supposed to do is analyze local traffic patterns, potentially considering specific mitigations, and then identify a specific tool to detect traffic and have sufficient situational awareness. And over urban areas, this could even be Flight Radar 24, for example. So, to conclude, we all know that the airspace is currently subject to a lot of restrictions, because if you remember the map I showed you from Belgium, like half of the airspace is covered with geographical zones. So operating within geographical zones, it's complex, but if the states are correctly implementing the procedures, then that should make it easier. But anyway, the whole process is managed through this flight authorization. We also discussed that at the moment, operations are only possible if the residual risk is reduced to a maximum of B. So the first thing that any operator should consider is implementing proper strategic mitigations to lower the initial risk up to B, if that's needed. But anyway, accessing the airspace remains difficult because these strategic mitigations may not be always available. U-Space was supposed to be the solution, but it's clearly not working because we don't have U-Space anywhere, almost anywhere in Europe. So we really hope that EASA and the Commission will listen to the sector and the stakeholders that are asking for allowing the provision of specific UTM services in uncontrolled airspace, for example, which could help in implementing the SORA tactical mitigations and also reduce the residual risk to a level of B. So that's all for today's webinar. If you want to know more about SORA in general, we provide SORA trainings, so just visit our website. And we have also been publishing a number of white papers helping people to better understand the new SORA 2.5. So you're welcome to download them. They are free. And if you need further support from us, please contact us and we'll be happy to help you. All right, that's all. So let me get to your questions then. So first question, using a temporary segregated area via NOTAM to reduce the initial air risk class to A would be valid for any flight height or only very low level? No, that would be valid for any flight height, so even above a very low level. It depends on the size of the temporary segregated area. So it's a solution also in other cases. Next question is, what are the density levels of traffic to classify an airspace as high density 1 or not? Well, this is a very good question, and to which unfortunately I don't have a clear answer, because this is something that has not been defined anywhere. So we could say that a high density airspace is typically an airspace over an airport. So that's the benchmark for a high density airspace. Everything that is close to that can be considered fairly high density, so would likely be classified at least at C. While on the other hand, the low density airspace is typically an airspace where you don't really expect to see any manned aircraft during your operation. So there might be manned aircraft flying there from time to time, but you don't really expect to see them during your operation. So this could be a qualitative kind of answer, but it really depends on the actual airspace you're flying in, and it requires expert judgment on the operator side and on the authority side. So unfortunately, and I must admit this, the air risk is still the most kind of controversial part of SORA. And as you know, it was not updated with the publication of 2.5. It will be updated with SORA 3.0, which, however, will be available probably in 2027. But the reason why it was not updated is because it's a very complex issue, because every airspace is different. So defining a methodology to kind of harmonize the way the risk is assessed is not easy at all. And even though the next version of SORA will make it a little easier, there will still be some kind of expert judgment involved. And there's nothing we can do about that. So let me see, are there any other questions? Oh yeah, here they are. So, can I explain detect and avoid, such as an onboard radar as opposed to electronic conspicuity? Where does that fit in? Are there performance requirements within the SORA annexes? So there are two different types of detect and avoid systems, the cooperative ones and the uncooperative ones. So cooperative means that the system detects the other aircraft thanks to some kind of signal or message that is sent by the other aircraft. And this is the case, for example, of the so-called electronic conspicuity, which might be based on ADS-B or Mod-S transponders. So this is how, for example, commercial airliners communicate with each other to avoid collisions. On the other hand, using radars is meant to detect aircraft which are not cooperative, that are not sending any data about their position and heading, for example. So both systems can be potentially used within the SORA framework. However, I might say that cooperative systems are typically cheaper to some extent, and often more effective, while radars may be much more expensive and their performance not necessarily adequate, especially for operations at very low level. So there's no specific indication in SORA on which solution to be used. The only performance requirement we have is that the system must be able to detect 50% of the aircraft in the volume. So how that is achieved, it's not told by SORA. So it's up to the system manufacturer to kind of demonstrate somehow that the system is sufficiently effective. Next question, are flights inside a CTR airport under 500 feet classified as air risk class C? Yeah, according to SORA, they are classified as air risk class C. So if there is no geographical zone and you are inside a CTR, your classification is going to be controlled airspace under 500 feet, so initial risk C. If the CTR is, however, inside a geographical zone, then the process to access the geographical zone might help you in demonstrating that the risk is already reduced to a lower level. Next question. In case of a temporary segregated area in proximity of an airport area, for example, an ATZ, would it also be needed an operation letter between a US operator and airport managers? Well, that would depend on what are the procedures that are implemented in that specific country for that specific airspace. I don't think there's one solution that fits all. And also it depends on where the temporary segregated area is located with respect to the airport procedures and facilities. So there might be situations where a kind of coordination is required through an operational letter, for example, cases in which when the area is active, operations can can just take place without any further coordination. Can Flight Radar 24 big data analysis a starting point to create dynamic traffic maps? Yes, absolutely yes. That can be used. However, Flight Radar 24 is typically tracking aircraft. I mean, typically, it's only tracking aircraft equipped with ADS-B. So you might be missing some of the traffic mix, especially at very low level in uncontrolled airspace. So it's a good starting point, but it might not give you reliable results in all kind of airspaces. Next question. Could you remind me why the operation of US in uncontrolled airspace is the most challenging one? Well, it's the most challenging one because in uncontrolled airspace, manned aircraft are typically not cooperative. So it's very difficult to detect them. And also, every uncontrolled airspace is different. So you might have an uncontrolled airspace where there's actually nobody, and an uncontrolled airspace that is filled with manned aircraft, because, for example, on a given day, there's a glider competition. So how can you really tell which one is yours? Well, you need to know that specific airspace. And this is already one challenge. The other challenge is that even if you know that airspace, you might realize that most of the aircraft there are not equipped with any kind of cooperative system. So your capability of detecting 50% might be not there. And therefore, this might prevent you from actually getting an authorization to fly there. So next question, or rather a comment. It says, SORA has a big difficulty to be adapted in all EASA areas. Have a look at Flight Radar, and you can see that Nordics and Baltic states have about 8 flights right now, and main Europe have 200. In my point of view, it's safer to fly in a CTR than Gulf space, because the air traffic controller owns the airspace and can handle it. We have been successful in getting ARCA in controlled airspace. Yeah, I fully agree with that. Right now, it's much easier and safer to fly in controlled airspace rather than in uncontrolled. But the reason for that is because in controlled airspace, even though you start from a higher initial risk, it's much easier to get to a lower residual risk thanks to the coordination with the air traffic controllers. So that's what's really helping. And that's something you don't have in uncontrolled airspace because there isn't someone you can coordinate with. So I absolutely agree that right now it's much easier to fly in controlled airspace. So that's why I stress the fact that to me, the key challenge is actually to fly in uncontrolled airspace right now, not really controlled. Is DJI planning to integrate a cooperative system device in their UAV? I don't have the answer to this. If Ling is connected, maybe she knows, but I can't give you the answer to this. How do we manage unusual air users in uncontrolled airspace, such as paragliders and paramotors hang gliders? Well, that's a very good question, and again, this is linked to the key challenge of flying in uncontrolled airspace. That it's, I would say, nearly impossible to manage such airspace users because they are often not equipped with any kind of cooperative system. So unless you know very well that uncontrolled airspace, and you know that depending on the environmental conditions, you can find there paragliders and gliders. There's no way you can tell in advance if you can expect to have that type of traffic or not. So the best solution is always to have procedures to somehow check the occupancy of the airspace before the flight. And this could be done through observers on the ground, through kind of interactions with relevant associations of paragliders or gliders. So there are different ways of doing that, but it's definitely very, very difficult to manage this type of traffic. All right, I think I've answered all questions I have right now on the list. So I'll give you a few more minutes if you have more before closing the session. All right, so it seems there are no more questions. So, well, then I thank you very much for attending this webinar. I hope it was useful for all of you. And once again, should you have additional questions or want to know more about SORA, please reach out. We'll be happy to help you. And then stay tuned, because for the time being, we have no other webinars planned, but there's definitely something going to happen in the future, again, in collaboration with DJI. So stay tuned, monitor DJI media channels, and we'll let you know what's coming next. Thanks a lot, and enjoy the rest of your day. Goodbye.